Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture. We have kind of completed or finished our discussion on the first aspect of the course, according to the design of this course, the lecture series, the geology or the science behind the mineral deposit formation, the different types of deposits that result from various crustal processes which are a result of the interaction of the lithosphere, hydrosphere and atmosphere, the way they evolved in time, giving us a very broad idea as to how the metallogenic processes have evolved in time. Sometimes we are in a position to make a good correlation with the processes that is operating presently with deposits which formed in the distant geological past. Sometimes they do not seem to be agreeing, sometimes they agree, and our pursuit or of our endeavor of investigating more and more on these deposits will continue, with the hope that they will enrich us with the knowledge which will be effectively utilized for discovering or such deposits in areas which are otherwise not known to be existing in those parts of the continents. In course of discussion, we also brought into the topic of these resources of the sea bed, which we did not look into it much with any greater details. We only discussed about the occurrence of the sea floor hydrothermal systems, sometimes resulting in rich mineralization of multimetal sulfides like copper, lead and zinc, and the seabed being a very rich resources of the ferromanganese nodules, which are just not important for their iron manganese content, but also for their content of nickel and cobalt, which the metals which are more important than iron and manganese at the present context. So, we now move on to the second component of the lecture series, that is the mineral exploration, and we will see how much we will be able to discuss on this, how much of insight we will be able to get, how much of our knowledge on ore deposits we are able to effectively utilize in exploration for the mineral deposits. And so, to begin with, let us first talk about a situation that once, so any mineral deposit, a mineral, an ore body, a mineral deposit, which is quite diverse in terms of its size, in terms of the metal content. For example, a deposit of an abundant metal like iron and aluminum will be present in terms of billions of tons and in areas of even hundreds of square kilometer, whereas a deposit of gold will be measuring only in terms of a few million ounces and will be just about only a square kilometer or a few square kilometer area as a deposit, although there could be some belts in which many such gold occurrences would be there in a particular terrain, like what we have seen in case of the ones which are occurring in the greenstone belts. So, there is wide diversity, but once an ore deposit essentially is an economic commodity for us. So, this has to be utilized for the economic growth, for various industrial purposes as raw materials and for the growth of the industry. So, now before we begin our discussion on mineral exploration, let us first talk about these mineral deposits or mineral resources as a special type of resources. We find that some specialties are there in these mineral resources. So, what are the specialties? Number one is that these deposits are exhaustible, non-renewable, in the sense that the quantity of the deposit of the metal which is present in a deposit if it is taken out, the rate at which we were exploiting them, which is always on the rise, that the demand is increasing and the rate of we can take a measure like a per capita consumption of a particular metal is on the rise. So, the time that these deposits, the time frame in which we are utilizing this deposit, exploiting the deposit is too short compared to the time frame in which the deposits formed by nature. So, they are all practical purposes the deposits are exhaustible, unlike any other resources that we talk about, where the exhaustibility or the non renewability does not come into picture. So, the deposits are uncertain. So, we have whenever we talk of any deposit, any resource, somehow we have some idea about the quality and quantity, whereas the mineral resources there is a lot of uncertainty about their quality and quantity. There is uncertainty about the usability, because today we do not know, I mean, what is going to be the technology future, and what is going today's any metal or any particular mineral, its usability as to what is going to be the future technology is not very well known. So, there is a bit of an uncertainty about the usability, which is not the case with other resources. They are finite in quantity. Any ore body we measure, we calculate by many different methods, which we will be seeing through our course of discussion, that whatever quantity it is finite, it is not infinite. So, it will be the particular rate at which we start exploiting it, it will get finished, get exhausted in a particular frame of time. Maybe in case of abundant metals like iron, it may last for about a few hundreds of years. In case of critical metals or scarce metals, it will be only in terms of a few decades or few tens of years. The other situation with the mineral deposits is that the depth dimension is not known. It has to be again to be investigated, to be estimated, to be assessed, that whenever there is an ore body, up to what depth it extends, and which is important for us. They are a result of complex geological processes. They do have locational and distributional peculiarities. For example, the ore deposits are not just located in very convenient places for us to go and just take them out, but they would be in the inaccessible part of the land where the mineral deposits are located. Perpetual, there once the deposit is there, it will possibly not be getting destroyed, bearing the situation that we discussed in the very beginning of this course about the self destruction of the cannibalistic recycling of our earth's own processes, which destroy the deposits in certain amount of time, but that possibly is in the geological time scale, not in the time scale of the human civilization. So, any deposit which is there will be there for eternity until and unless the deposit is being exploited. It does not get destroyed by any process any in short time duration. And these deposits, the mineral deposits, they are peculiar in the sense that they do not abide by any geographical boundary. We have seen one example, such a Cooper Schiefer is a huge body of copper bearing shale, which extends for 600,000 kilometers in Europe and occurring in many different countries like Poland, Germany. There are many examples in the Indian context also, even if we talk about state boundaries. So, mineral deposits, they will be transgressing through the geographical boundaries, and the relationship with economy is also something very interesting, and that is the reason why we say that we have to formulate, because that is also a little bit of an uncertainty, that how the mineral resources are going to be exploited and how the economy will grow. We will take up a few such cases where we will demonstrate that it is not always true that a mineral deposit, a country will be getting the full economic benefit out of presence or the existence of a certain mineral deposit or not. Okay, so before we go, so then it's important that we do classify these mineral deposits. Before we go for the classification of the mineral deposits, let us first get ourselves acquainted with some of the terms which are used in the context of mineral deposit. Whatever quantity that a mineral deposit, a body, an ore body would be present in the earth's crust in its dimension in space, length, breadth and depth. So, it will be a quantity which can be measured, directly can be measured and calculated, and we will use a word which is called as reserve for that. That is the reserve of that particular metal. That is be in terms of a few billions of tons or millions of tons or millions of ounces, or in case of liquid resources like fuel, oil, we express in terms of billions of barrels, or in case of gas trillions of cubic feet. So, that is what exactly the terms reserve is, quantity that is to be reported, because whenever we are we did not give much of a statistical data about the mineral deposits, but every deposit, the figures that one would always look for is what is the reserve of that deposit in terms of, if it is a metal multi-metal deposit, say deposit of copper. So, it say that what is the total amount present in terms of millions of tons. So, that one can make a calculation that if that particular metal will be produced in certain millions of certain tons or certain thousands of tons per year, then how many years this particular mine is going to last. So, the reserve we basically categorize as measured, indicated and inferred. So, measured is the one, means we say that measured is here is, this is measured means the quantity is actually very certain, that we can tell that this much of the metal in the form of the ore is present in the ore body. A little less certain than that will be indicated. Here the degree of confidence will be little less than that what is to be reported as measured, but it would be quite probable. And the one which is inferred means about this is just by using our extrapolations or speculation, we can say that okay. So, for example, while reporting the quantity of any particular mineral deposit, we may say that this x millions of tons of is measured and x plus m million tons. So, this m is actually the amount which will look to be quite probable based on data which possibly would be reliable, but not that very closely spaced or not very certain, as we will basically be going to the procedure of reserve estimation will be clear at that time. So, that is the which would basically be. So, this measured and indicated together could be basically be the one which can be projected as the reserve base. So, the one which remains as totally speculative, which can only be further proved to increase the reserve of a particular deposit, is basically inferred, and the equivalent terminology which were used for a measured we can say it is proved, or for indicated we say probable, and for inferred we can say possible. So, when we take these two together, proved and probable, or say measured and indicated together, so this actually constitutes something which is called the reserve base. It is just not only that in terms of the degree of confidence or the degree of certainty about their quantity parameter, there is also something else to it. We will just see. Okay. So, this is a classification scheme of mineral resources. This is very popularly known as the McElway's box. So, as we were just discussing about the classification as to reserve and resource. So, this box this gray part total, this gray part total is basically the resource, out of which we just if we go by the terminology of measured, indicated and inferred, the one which is measured and indicated is basically being shown as reserve, and inferred. So, here we have two different two axes. The horizontal axis is indicating geological certainty and the vertical axis is actually representing the economic viability. So, in the economic viability we can have economic, marginal economic or sub economic. So, economic actually will be coming out from the suitability or for the economic viability, in the sense that the material which we are taking out as ore, from that the metal of interest or the metal or metals of interest can be extracted at a profit, depending on the current technological advancement or the current technology of the extraction is available. So, it is essentially that is where economic, engineering and environmental factors all together mixed on one, and within those constraints whatever material is coming out to be usable, and that will be taken as our ore, which will be subjected to processing and further beneficiation or extraction of the metal, which will be considered as the reserve, measured and indicated. Now, from the measured indicated, even though we might have calculated the total quantity that is present in a particular ore body, but the entire quantity may not satisfy the quality criteria. For example, so from there we will further define these terms later. So, what we say is a grade of an ore, and so this grade of an ore essentially is something which is acceptable in terms of the quality of the ore, which can be amenable to further treatment processes which requires investment, and also further extraction processes which also involves investment. So, the total amount of cost that is invested on getting a unit mass of the particular mineral or metal should be satisfied, and is basically defined by something which is called a grade, and the lowermost limit of the grade has to be fixed by us. For example, if we take an ore of copper, then if the copper weight the percentage of weight in an ore is less than 0.45, let us say for example, then that particular material, even if it is an ore and you have calculated the total tonnage, but any part of that particular ore body where the concentration of that metal falls below 0.45 weight percent, that cannot be considered as an ore, and that will be discarded as waste. That will be discarded as waste. Now, the situation is that why this y axis is kept, because the economic, engineering and environmental factor, where something is economic and something is marginally economic over here. So, the difference between the economic and marginal economic might turn out to be a matter of time, because it might so happen that the technology which was available before, which was able to extract metal from a particular ore only when its grade was above a certain particular limit, but later on with the advancement of technology it may be possible to treat or to process that particular ore with still further lower concentration for its further processing and extraction. So, in that condition, what was marginally economic might become economic. So, this boundary is essentially very dynamic, and what is considered as sub economic means the ones which the material or the concentration of the particular metal is so low that possibly in a foreseeable future also it could not be considered as an ore. Giving a small example, the gold deposits that we were talking about in the Indian context, when they were initially discovered, the concentration of gold was possibly of the order of 10, 15 or 20 grams per ton or ppm, even sometimes when we see the bonanza type of gold deposits where the concentration of gold can go to 30 grams per ton, 30 ppm, and initially depending on also the economic factor like the amount of investment that is put for extraction of a unit mass of that particular metal and the price at which it is sold in the market will definitely decide that. So, possibly 50 years back a 1 gram or a 2 grams of gold per ton of the ore might have been discarded as waste, but at this present time with the increasing price of gold it might be considered as an ore. This is just an example. So, this is how this boundary, although this is put, this is dynamic and this is very transient, but then this gives us a framework in which to classify the mineral resources into different categories. Now, the other thing to know about in this whole Mackelville's diagram is that the one which is measured and indicated is put under the category as demonstrated, and the one which is inferred is kept separately, because this is the part of the resource about which we do not have a direct evidence or a direct proof, or we have not physically intercepted or have sampled the ore. So, then when this, so here the measured and indicated which is coming out to be reserve, and then when it is again combined with whatever resources which is inferred and up to marginal economic. So, this will be the box which will be the reserve base. So, this will be the reserve base only up to this. This is the reserve base. Now, you could possibly recall when we were plotting about the quantity versus crustal abundance, we were essentially plotting the reserve base versus the crustal abundance, because by plotting the reserve we will not get a clear idea. So, we will have to take into consideration the material which are considered to be economic at this particular point of time, and the materials which also is likely to become economic in the foreseeable future. These also have to be combinedly together considered to give you the idea about what is the total amount available with us, and that is how is the log of reserve base versus log of crustal abundance was plotted on our diagram, which we used in the introductory part of the lecture series. Now, if we look at the full box, so then we are classifying it broadly into identified resources and undiscovered resources. So, this particular box is entirely unknown for us, this particular box, and one might wonder that if this is the subset of the resources that we have already discovered, and the area which is undiscovered. So, as it looks like the proportion that we may be having a lot more to discover, but there is no certainty on that. This is absolutely very schematic, because you never know that whether the area that is represented in terms of the undiscovered resources, which are hypothetical and speculative, which is basically our probable kind of resource, they may be either very small in their size proportion compared to what has already been discovered, or maybe even be very large. This is the part which we are not very sure, and where the entire domain of exploration is based on that. That we may possibly be able to discover a lot more large other deposits than what we already have, or the other school of thought, or rather exactly the opposite view could be that, well, we have possibly explored, or we have possibly discovered what all we could discover, and whatever we have, that is possibly the end of it, and we possibly do not have much more to add to that. That could be the other, but somewhere if we could take a stand which is really intermediate between the two, that we still can explore. For example, as I was telling, we are only 30% of the surface of the earth that is available to us as the continents on which we are able to explore, and we also know that the the volume or the area, the total area which you can call them as virgin or has never been seen by human eye is also shrinking, or at least non-existent right at this point of time. So, the only way that we can think that we will be able to increase the total quantity that is available to us is the hope that we will be adopting some newer and newer technology for our exploration and exploitation as well, because in the very beginning when we were discussing about where exactly we get this ore deposit, we said that we are restricted to just about top 2-3 kilometers or maximum 5 kilometers from the surface. We might even think of going further deep and might even develop technologies to give us the indication of what is lying at depths which are greater than that, and we should be in a position to explore them, exploit them. Or even the other part of it is that we could also start exploring on the ocean floor and start getting the exploiting the ocean floor resources. So, these are the ideas that we can have. So, this is a classification scheme that is known as the McKelvey's box. If you see standard textbooks, you can see there are lot of such diagrams which are used. So, this is essentially for mineral resources. There are many such classification scheme proposed for coal and other kind of resources which I am not not discussing here. This gives us a introductory idea and which is important. When we were discussing about these categories of the mineral resources in terms of reserve, the reserve base, or what basically we can call, if we take the whole thing, the whole box together, we can call it as a total resource base. And if someone asks that what is the ultimate available resource for a particular metal, you could possibly say that, well, the average crustal abundance of a particular metal, take the volume of the total crust, multiply the density, get the total mass of the crust, and then multiply that factor of abundance in terms of 10 to the power minus 6. Say for example, take a copper which is 50 ppm, and if you multiply the total mass of the crust, then that is possibly the ultimate available resource for that particular metal. And but we all know that we won't be able to get that. We will be getting what actually be the ultimate available resource will be much less than that, which has to satisfy the quality quantity parameters. The problem with this, it is not exactly the problem, but there are lots of non-uniformity in reporting the mineral resources by different countries, different parts of the world. So, that is the reason why the United Nations adopted a framework classification which is very widely known as the UNFC or United Framework Classification, that arose because to have an uniformity in reporting of mineral resources of different countries. And so, there must have been, because some people are reporting in terms of measured, indicated and inferred, or possible, proved, probable and possible, and many other different ways which can be the resources could be expressed. So, we need to have a common uniform code of reporting of mineral resources, and United Nations framework classification was proposed for that. So, let us go and let us have a look of what this United Nations framework classification is. What we saw in the McKelvey's box, what was presented on a 2 dimension with a geological certainty on one axis and the techno-economic parameter economic feasibility on the y axis. Now, this is a little bit more elaborate and is a little bit more convenient on the way of expressing the type of resource to which it belongs. For example, we can have a socio-economic. So, what is presented here is the first is the socio-economic viability. So, this is the axis 1. So, here this is divided into E1, E2 and E3, because any particular mineral resources, in order for that particular deposit to be qualified as an ore body and the investment to be made on its exploitation, it must also meet certain socio-economic viability, even environmental parameters also included in that, which we will be discussing in the last part of the lecture series about the environmental impact. And So, what is going to be its impact on the socio, because one deposit might turn out to be pretty rich in terms of its metal content, in terms of project feasibility also it might turn out to be rich, but then it might fall off not being able to meet the criteria of socio-economic viability. So, this socio-economic viability is absolutely qualitative, it is E1, E2 and E3, where E1 represents. So, in this case E1 is greater than E2 is greater than E3, means the bottom one would be considered as the least viable and the top one is the most viable, and the y axis is project feasibility. So, feasibility is actually coming from this consideration that once a deposit is discovered, its quality quantity parameters are estimated, whether the investment on that particular project would be feasible or not, which will be also considering during the course of our lecture, what essentially is understood by this project feasibility. One deposit may be rich, may be the quantity may be very high, but it may not still be very feasible on to invest on this particular project, because the demand of that particular metal may not be that very high in the market, and there could be many other possibilities. And the third is the geological knowledge, the certainty about the geological, the existence or the existence of the particular deposit, whether how certain we are. So, in most of the thing that we are going to follow is basically is that, so G4 is the lowest, followed by G3, then G2 and G1, means if we are labeling some deposit as belonging to G1, means it is quite certain that we know it exists and its identity is established, its dimensions in terms of length, breadth and width is also established to a great degree of certainty, compared to one where we could possibly just speculate that a particular deposit might be existing in a particular geological terrain, because it satisfies certain geological conditions as far as the knowledge, our knowledge is concerned. And if you remember, we also while discussing the attributes of these mineral deposits, we discussed that an ore deposit occurrence is essentially something like a chance in nature, because given two identical geological setup, one cannot say with any degree of confidence that in one case if a deposit is occurring, the other case the deposit also will occur. So, we will continue discussing on this before we go to exploration, and the whole objective of exploration is basically to go from G4 to G1 in this direction, and also make look for projects which are basically be called in F1, means the highest feasible and also economically most viable. So, the blocks which are shown in the color of 1 are essentially the commercial projects which are in operation, where the deposits are being worked out and the metals are being produced, and the ones which are given in say for example, this one, this 344 is essentially there is absolutely it is out of, there is no known knowledge about that, this additional quantity is in place. These are the exploration projects 334. So, this nomenclature only results in labeling the deposits in these 3 digits. So, 344 to 111. So, 344 which is absolutely the one end of the spectrum, whereas 111 is something which is the commercially most viable and the commercial projects. So, we will continue discussing on this before you go for the mineral exploration in the next class. Thank you.